Hello everyone. Today we will be discussing on some questions or numerical based on basic concepts of properties of fluid. Let's start with the first question. The density of fluid increases with bit A, pressure increases, bit B, pressure decreases, bit C, pressure remains constant, and bit D, none. Let us understand this with simple example. Let's say a piston cylinder arrangement with some fluid. To this piston cylinder, to this piston, a some pressure is applied. It means pressure on this piston is increases. We know the relation, that is density equal to mass per unit volume. As pressure increases, it means the volume of this particular mass is decreasing. This volume is decreasing due to this increased pressure. As volume is decreases, the density of the mass within this space is increasing. So, we can say that the density increases because of volume decreases, and this volume is decreases because of pressure increases. So, here we can say that the density of the fluid increases with pressure increases. So, bit A is the right answer. Next question. Newton's law of viscosity depends upon the bit A, stress and strain in a fluid, shear stress, bit B, shear stress, pressure and velocity, bit C, shear stress and rate of strain, and bit D, viscosity and shear stress. So this Newton's law of viscosity states that shear stress on a fluid, that is tau, is proportional to rate of shear strain or rate of deformation, that is d theta by dt. So from this expression we can see clearly that Newton's law of viscosity is dependent on shear stress and rate of strain. Next question. So this is a numerical. The shear stress developed in a lubricating oil of viscosity 9.81 poise filled between two parallel plates 1 centimeter apart and moving with relative velocity of 2 meter per second is bit A 20 Newton per meter square, bit B 196.2 Newton per meter square, bit C 29.62 Newton per meter square, bit D 40 Newton per meter square. So see, in all these options, the units are given in SI unit. So remember, while we solve the numerical, we convert all the units into SI units. So the data given in these questions are dynamic viscosity, that is mu equal to 9.81 poise. Let's convert this into SI unit, that is 9.81 into 1 by 10 Newton second per meter square. dy is 1 centimeter, that is the distance between the two parallel plate, and it becomes, that is in SI unit, it becomes 1 by 100 meter, and du is the velocity with which the fluid is moving, or that is the lubricating oil is moving, that is du equal to 2 meter per second. We know that tau equal to mu du by dy. So this is the mathematical expression of Newton's law of viscosity. So from this expression we find out the magnitude of shear stress, that is tau. So tau, in this equation we substitute the value of, that is mu, du and dy. So these are the value, that is mu is 9.81 into 1 by 10 into du is 2 meter per second 2, and that is dy is 1 by 100. So now take this 100 into the numerator. So this is written here in this expression. Now after solving this, we get the magnitude of tau equal to 196.20 Newton per meter square. Next, another numerical. The equation of a velocity distribution over a plate is given by u equal to 2y minus y square, where u is the velocity in meter per second at a given point y in meter from the plate measured perpendicularly. Assuming mu equal to 8.60 poise, the shear stress at a point 15 centimeter from the boundary is, and the options are A is 1.72 Newton per meter square, B is 1.46 Newton per meter square, C is 14.62 Newton per meter square, and D is 17.20 Newton per meter square. So see, all these options are given in SI unit. So convert all the units into SI units while we solve the numerical. So the data given in these questions are mu equal to 8.60 poise, that is equal to 8.60 by 10 Newton second per meter square. This is the SI unit. And the equation given here, it is u equal to 2y minus y square. Another data, that is y, that is equal to 15 centimeter equal to 15 by 100 meter. So in this question, what we have to find here? We have to find out the shear stress. So for that, we use the relation tau equal to mu du by dy. So for that, we need to differentiate this equation u equal to 2y minus y square with respect to y. So after differentiation, so the expression will be du by dy equal to 2 minus 2y. So next we have to find out the magnitude of du by dy at y equal to 15 equal to 2 minus 2 into 15 by 100. So this 15 by 100 is what? 15 by 100 is, that is the magnitude of y in SI unit, that is 15 by 100 meter. So that is equal to 1.7. So after substituting this value in this equation, tau equal to mu du by dy, we get the value of tau to be 1.460 Newton per meter square. This is the magnitude of shear stress. So here is the next question. What is the unit of dynamic viscosity of a fluid term poise equivalent to? So we know that one poise equal to 1 by 10 Newton second per meter square, right? So here we can say in CG's unit, this Newton is expressed as dyne, second remains same second, meter is expressed as centimeter square. So this bit C is the right answer, that is dyne second per centimeter square. Newton's law of viscosity relates bit A velocity gradient and rate of shear strength, bit B rate of shear deformation and shear stress, bit C shear deformation and shear stress, and bit D pressure and volumetric strain. We know that Newton's law of viscosity states that shear stress on a fluid is proportional to rate of shear deformation, that is d theta by dt. So from this expression tau is proportional to d theta by dt, we can clearly see that the option B is the best possible answer, that is rate of shear deformation and shear stress. Next question. The equation of a state for a liquid is P equal to 3500 rho to the power 1 by 2 plus 2500 Newton per meter square. The bulk modulus of liquid at a pressure of 100 kilopascal is option A 3500 Newton per meter square, option B 2500 Newton per meter square, option C for 48,750 Newton per meter square, option D 6,250 Newton per meter square. So here we have to find out bulk modulus, that is K equal to rho dP by d rho. So this is the expressions we have to use to find the magnitude of bulk modulus, that is K. So here is the data given in the question, that is P equal to 100 kilopascal, that is equal to 100 into 10 to the power 3 Pascal. So that is the SI unit, because all the options given in this question is SI unit. So first, here we find out the magnitude of, that is rho, that is density. So we use the equation P equal to 3500 rho to the power 1 by 2 plus 2500 Newton per meter square. So in place of P, we substitute, that is 100 into 10 to the power 3, that is given in the question, is equal to 3500 rho to the power 1 by 2 plus 2500. Now if we solve this equation, we get the magnitude of rho to be 776.02 kg per meter cube. Now we differentiate the given equation P equal to 3500 rho to the power 1 by 2 plus 2500 with respect to density. So that becomes dP by d rho equal to d by d rho into 3500 rho to the power 1 by 2 plus 2500. So after differentiation, that is dP by d rho equal to, so this is the first term. If you differentiate this with respect to d rho, we get 1 by 2 into 3500 by root over of rho. And this is a constant term. So if you differentiate this with respect to rho, that becomes 0. So here we can say this dP equal to 3500 by 2 rho into d rho. Already we know that K equal to rho dP by d rho. So we get the value of rho and we get the value of dP. Now we substitute the value of rho and dP in this equation. So that becomes K equal to rho into 3500 by 2 root over of rho into d rho, and this d rho remains as it is. So this d rho cancels each other, and the expressions left here, that is 3500 root over of rho by 2. Already we get the magnitude of rho, that is 776.02. So after substitution here, we get the value of K, that is equal to 48749.98 Newton per meter square. But in the options, it is given that the nearest value, that is 48750, that is Newton per meter square. So this is nearest to this value. So we go for this option, that is 48750 Newton per meter square, that is Pascal. So this is all about today's lecture. Thank you.